Hey guys, so basically what I'm going to do is kind of walk you through these videos and save you a little bit of time, try to kind of go as quickly as I can. So basically what I'm doing here is I'm running hot water in to this aquarium. It's a 10-gallon aquarium. So basically what I'm going to do is fill up about halfway with hot water and then come in and put cold water underneath. Just as you guys know, like in a house, hot air rises. So usually if you have 2 floors in a house, the upstairs is going to be a little bit warmer than the downstairs. Same thing happens in water. Warm air rises, or warm water rises. Cold air is going to sink. So cold air or cold water can force warm water up. So the next video basically shows me piping in cold water, and the way that I do that is I just got a cup here and filled it with ice, and then started running colder water excuse me, in through so that it comes on the bottom. And you can actually see as this runs and go a little further, you can see little waves down here of kind of like heat waves rising off the street, but they're kind of the cold waves in this case. And it's just that temperature gradient difference between the two temperatures of water basically allow you to see. You can see right there the little heat wave things. So anyway, as I get that set up, we don't need to watch the whole thing, but basically I fill it up and then we can go on to the next one. So what we do in the next one, we're gonna basically put, if I did everything right, basically it's cold water on the bottom, warm water on the top. So I'm going to pipette blue water, or blue food coloring into the bottom, red food coloring into the top. So it should look kind of like this. So there goes the blue. Notice it stays in that bottom layer. And then you'll really see with the red, as it goes in, I'll just let it go. See how it wants to come in, but then it sinks to a certain point, but then doesn't really want to go further. That's because this is a warmer layer, so the food coloring is coming up to temperature of the water as it slowly sinks, and then it stays at that level. So sorry, my head got in the way there. So if I go a little further, basically that's what we're looking at. Now for something that we're going to talk about with this, basically we want to blow on the surface. So we're gonna apply this to kind of real world scenarios. So if this were, for instance, a lake, and this were, you got a cooler layer at the bottom, you got a warmer layer at the top, so it's probably like summertime, right? If you've ever been in the lake, you'll actually see kind of in this zone between the two, you'll see these plumes of color moving throughout there. You'll see those in just a minute when we start doing this, but basically what we're doing is we're going to blow on this, and I asked you to predict how you thought it would mix. So we've got the warm layer on top, the cold layer on bottom, and then I'm going to blow across the top. And I really probably should have thought this out a little bit better, because using a big fat aquarium like this, I probably should have used a fan or something, because blowing makes you tired. So I'm gonna let it go. I'm gonna let you see it. I'm going to talk kind of as we're going through it. So you can kind of see, I'm just going to draw this right there so you can kind of see that's where the layer is, right? All right, so I'm going to run it back here. I messed up there. So I'm starting to blow on it here. You can see that right here is mixing. It's easier to kind of see if I do it in that fast motion sort of thing. So see, we're blowing on it. It's wanting to mix, and really it's mostly mixing kind of on this end first, right? Which makes sense because that's where the heavier wave action is. So if we let it roll a little bit, kind of do it in that fast motion, notice how that's starting to work its way this way. So watch this right here. So come back, notice it just starts working its way this way. And then really down here, there's not a whole lot of mixing going on. And at the very bottom, notice the blue hasn't changed at all. And that's what's really important to see, right? And so if we keep going, you'll see eventually we have a pretty well mixed top layer, and the bottom layer is pretty well untouched, right? And then let me let this run kind of at slow right here, just so you can kind of see it. But you can see these little areas down here, and this is why if you're in the lake in summertime, you might feel these little plumes of cold water come through and brush by you, right? So let's move to the next video here. So in this one, I basically am going to start disturbing it a little bit more, and I just want you to see how well insulated this area is. And then you can see these plumes, right, moving around. There's not a lot of mixing though, it's still resisting that mixing. In the next video, I get you a cork, kind of show you the same thing. And you can see the temperature difference is starting to change. There's a lot more motion in this middle zone, right? And basically just putting in a cork here so you can see cork doesn't move as much the lower it gets, just so you can see that's not mixing. Now, when this gets really close to where there's not very much of a temperature difference, whenever we start to disturb the water, we'll get where this blue layer starts to mix more. So in this particular case, as I start to mix the water more, you see how it intrudes down into that bottom layer more, right? And then once that happens, we start to get the mixing from the bottom, right? And if I were to simulate as if the wind were blowing, then notice how it starts to mix just as that top layer did before. So as the temperature gradient between these two layers gets smaller and smaller, so in other words the temperature gets closer to each other, then the entire column can start to mix. So basically from this video you should see that water can have different densities based on temperature, and then those densities can form layers in the water that actually lead to stability within the water column. And the word for these layers, I'll kind of break it down in another video, but it's going to be called thermal stratification. Stratification just means layers, and then it's based on thermal or heat of the water. So that's basically what I wanted you to see from this video. It's just how water would mix, and then we're going to kind of link that to what that looks in the real world. So for now, key features are water is a different density at different temperatures. And that different density will allow it to be more stable to changes. So we'll leave it at that and move on.